Hindi ko lang yung aking background at nakikita yung aking LEC. So, punta tayo doon sa expressions of analytical information. So, since analytical chemistry yung spectrochemical analysis, nag-a-apply pa rin dito kung ano yung ginagawa natin sa analytical chemistry. So, it's always extended to that part. So, sabi nga natin, several different types of info are required in order to develop, optimize, and apply yung tinatawag nating analytical technique. Now, the question that we have is how to express yung spectrochemical info in a convenient manner so that analyte concentration data can readily be extracted. So usually ang inaano naman natin we are determining the concentration of the analyte. So the question is, how can we extract readily the data of the analyte information? O ano ba yung effect niyan? Let's say, kung meron tayong tinatawag na chemical, physical, or instrumental variables that are involved. Okay? So the dependence of the results with the chemical, physical, or instrumental variables can easily be summarized. At pwede nating i-discuss yan in terms of yung tinatawag na calibration data, atomic and molecular spectra, at yung optimization of the response function. Okay, so we all know that we cannot directly measure yung analyte. Okay, so the desired concentration of the analyte is almost never obtained directly. So wala talaga tayong direct way na, let's say, any instrument, pag nilagay mo yung sample mo, sasabihin agad sa'yo kung ano yun. Siguro, science fiction yun, Star Trek. Parang analyze the specimen. So, wala pa tayo doon sa level na yun. Okay? So, everything that we do, we could say is, we use some sort of a reference o yung tinatawag nating standard. Okay? So, dito pumapasok yung tinatawag na calibration data. So we cannot directly obtain the desired concentration of the analyte, but the concentration can be obtained indirectly through calibration. And I think this is not only true sa spectrochemical. Sa lahat yan. Okay? Sa mass spec lang yata yung meron tayong ano ngayon na kaya niyang i-identify. Okay, but if you're going to look at electrochemical or chromatography, okay, besides the mass spec detector, you cannot measure directly the concentration. Okay, so you have to do it by indirectly through the so-called calibration. So calibration, tapos ano pa isa? Subtraction of blanks or blank subtraction. Comparison with standard. Tsaka other procedure. Pero yung pinaka-common ay yung tinatawag natin yung calibration. So pwede natin makita yung signal na nakukuha natin. So whenever we have a sample and let's say we get the absorbance of that, yun yung tinatawag, ang nakukuha natin doon ay yung total spectrochemical signal. So it's defined as the unmodified readout signal obtained from measurement of a sample or standard. Okay? So siguro kapag sample, pwede natin makita yung absorbance na ganito, maingay. But if we have a standard, usually medyo narrow. Okay? So, ito, if you have a sample, this is just the results of the addition of all compounds that are present in a given sample. So yun yung tinatawag nating total spectrochemical signal. So wala kang ginawang blank subtraction, wala kang binago. Okay? As much as possible, you want to get, let's say, the absorbance of your sample or the absorbance of a standard. So ang difference nga nung dalawa, mas malinis yung sa standard. Okay? Now, if we want to analyze, okay, or to get, let's say, the concentration, we usually have the so-called blank or yung tinatawag na reference signal. So itong reference signal na to or blank, this is just defined as the readout signal obtained from the measurement of the blank. So usually we want the blank to be as much as possible, ano? Kung possible, ang ideal blank or reference signal, gusto natin, di ba, straight line lang. But how do we do? Let's say we have a blank and then we want it to be straight line. Paano natin inaano? Let's say pag nag-aano kayo doon sa spectronic 20. Spectronic 20, wala kang choice eh. Kailangan mong kunin yung signal. Tapos i-subtract mo lahat. But yung ibang, we could say, spectrophotometer, pwede mong iset kung ano yung blank mo. Tapos, pag mineasure mo doon sa instrument, pwede mo siyang iset na blank. So, automatically, magiging zero siya. Pag sensitive yung instrument mo, makikita mo ganun. But if you're going to look at the reading, usually it's 10 to the -4. Masyadong sensitive. So, yan yung tinatawag natin, noise lang yan. We just see that it's so high because the point of comparison is so small. But if you're going to compare it, let's say with a sample signal, straight line pa rin yan. So yan yung tinatawag nating blank or reference signal. That's why we discussed last time, we want the blank to be everything except the analyte. Okay? Kasi if we have the blank and then we have the sample that contains the analyte, so any signal minus the blank, yun yung tinatawag nating analytical signal. Okay? So yung analytical signal natin, ito yung na-extract natin from the total spectrochemical signal. And ideally, this is what we want. It should be directly related to analyte concentration. So yan yung pag inano mo, let's say absorbance, so ganon, tapos tataas kapag mataas ang concentration. Tapos, what we do is we can get the wavelength here. Tapos, titingnan natin yung concentration. So, makakakuha na tayo ng parang tinatawag na calibration curve. Okay? So, I think all instruments, they have this calibration curve or one way for you to determine the concentration indirectly. Okay? Kahit yung mass spec, kung ma-identify man niya yung identity, hindi pa rin niya na-identify yung concentration ng material. You still have to make either a single standard addition or a single standard comparison or di kaya yung tinatawag na calibration curve. Okay? So, doon sa mga automated instrument, yung readout signal, yun na usually yung analytical signal. Pero kapag spectronic 20 yung instrument mo, so kukuha ka kung yung blank ay ganon, okay? So mangyayari yung sample mo, malamang may ganon din, tapos may ganon. So all you need to do is you subtract all your signal doon sa blank mo. And it's really tedious. Okay? Kasi minsan, mas mataas pa yung ano mo dito kaysa doon sa sample mo. Ang nangyayari kapag nag-block subtract ka, parang may dip doon, tapos may ganun. But you're only after yung signal dito sa part na to. We remember, I think, in fluorescence. Okay? So fluorescence, yung water, meron siyang nai-emit na Rayleigh scattering. So nangyayari namin, kapag hindi fluorescence yung sample, ang mangyayari, laki niya. Tapos ganun lang. Now, kapag fluorescent yung sample, minsan hindi mo na siya makikita, ang liit lang niya, tapos taas, sobrang taas ng signal mo. So kapag inano mo yan, yung kikita mo na yan. So anong gagawin mo kapag gusto mong i-publish yan?
Cut na lang yung wavelength.
So puputulin mo to. Hindi mo ipapakita yung pangit. Pero sasabihin mo pa rin na you blank subtracted it. Parang yung carelessness nga yung undergrad ko. Hindi ko rin nakita doon sa paper namin. Yung blank namin, sabi namin, ang blank namin is pure ethanol. Tapos naalala namin, yung palang in-extract namin sa ACE is 3:1, 3 ethanol to 1 water. So parang comment ng reviewer, although this will not affect so much the signal, but you should know that the blank should be equal, should be the same as the 3:1 and not just pure ethanol. So sabi ko nga, ba't di mo yun? Hindi ko alam paano sabihin sa editor, hindi ko pa sinasagot yung paper namin kasi kailangan ka mag-comment dun . But that's usually what we usually do. We blank subtract it. Okay? So, kapag meron kang tinatawag na calibration curve, usually this is just the plot of the analytical signal versus the analyte concentration and with all the other variables in the calibration function held constant. Okay? So kung ano yung temperature, kung ano man yung variables na meron kang ano doon, dapat pareho sila. Ang difference lang ay yung concentration. So hindi sila pwedeng different solvent. Okay? Hindi sila pwedeng different temperature. So dapat yung variable lang na nagpapalit sa kanila or nagbabago ay yung analyte concentration. Now there's other words for calibration curve. We can call that working curve. Tsaka ano pa? Yung tinatawag na analytical curve. But when we go on in each what we call method, makikita nyo na hindi lahat pwede. Okay? When we have the so-called Beer's law, when we go to absorption, so makikita mo, hindi ibig sabihin na mayroong calibration curve forever na yun. Because in the Beer's law, what will happen is parang ito yung concentration niya, ito yung signal. So there will come a time na ganito yung magiging reading mo. Okay? It can also happen in the emission. So usually, kapag ganito, anong gagawin natin?
Dadilute, sir.
Idadilute or ipuputulin mo na lang yung... Kasi calibration curve to.
Pwedeng putulin na lang din, sir.
Yeah.
Hindi na po i-consider yung higher concentration.
Yep. So what we do is we just limit this one here. It happens in emission. Ang tawag doon quenching. Pag masyado nang marami yung concentration, na mataas na yung concentration, nagque-quench na sila. So pag sinabi nagque-quench, yung hindi lahat na-excite dahil sa sobrang dami. Okay? We will go on that portion kapag pagdating natin dun sa fluorescence. But all we need to do na is yung calibration curve ay hindi yan forever na ma-extend mo. Okay? So, ang pwede mo nang isiguraduhin dito that when you work with your sample is within the calibration curve. Now, kapag ang signal niya ay mataas, just magdadalute. And make sure that the signal that you have is within your calibration curve. You just take note kung ano yung dilution factor na ginamit mo. So yan yung calibration curve. Just like in any analytical techniques, okay, ginagamit din ito sa what we call spectrochemical analysis. In fact, yung iba nga, they were able to patent doon sa mga dinevelop nila to measures yung mga biological fluids like urine and blood. So what they do is, usually meron silang calibration curve na ganun, di ba? So it's just concentration versus the signal. So if you follow Beer's law, ano ba yung Beer's law? A equals to ABC. And usually, yung B naman is always 1. So you can just put this as what we call KC. Yung K dito, yun yung tinatawag mong molar absorptivity. So what they do at a certain wavelength, so kapag meron silang, let's say, complexing reagent, yan yung ano ng mga iba't ibang ano yung company, yung bilirubin analysis, calcium analysis. So what they do is, whatever the absorbance that they have, okay, i-divide mo lang doon sa molar absorptivity, ibibigay na sa'yo yung concentration. So they have developed already that thing. Not only developed, nakapatent na yan sa kanila. Kaya minsan makikita mo, bilis naman nilang makakuha ng results. Okay? So, since meron tayong spectrochemical analysis, so nandyan yung tinatawag nating spectrum o yung spectra in plural. Now, ito yung, hindi talaga ito yung toroidal. Ito yung parang plot na makukuha natin. Okay? A plot of the analytical signal versus wavelength, frequency, or wave number. Okay? With all the other variables held constant. Okay? So ito na yung makikita natin na ganun. Or we could say absorbance. Kapag ano, wavelength dito, kapag emission, ang tawag natin is intensity. Okay? Tapos kapag IR, so instead na wavelength, so meron tayong 1 over wavelength, wave number. Tapos ang tawag natin dyan is either absorbance. So pag absorbance pataas. Pero ang commonly na ginagamit nila ay yung transmittance. Yung galing sa taas. Okay? And we will not, when we go to each of these method, bakit yung absorbance pataas, bakit yung transmittance pababa. Okay? So yung peaks na makikita natin, either lines or bonds, they are characterized by their shape, height, which is the intensity, width, and position. Okay? So, yung peaks, ang common na makikita natin ay yung tinatawag na bonds. Yan yung mga peak. You seldom see a line. Okay? Siguro sa atomic absorption, it's a line, but you don't really see a line, you just see a number. Okay? So usually the width is expressed as the half width. Okay? Which is the width in wavelength units at half the net peak height. And yung term na ginagamit niyang half width ay yung FWHM. So kapag merong kang peak, ito yun. And it's very useful in spectroscopy. Okay? I remember in Daraman, pinapaano sa amin, pinapadetermine yung full width at half maximum. Because it will tell us kung yung environment mo ay homogeneous or heterogeneous. Okay? So sa tingin nyo, alin yung mas wider? Homogeneous or heterogeneous environment? Ano sa tingin nyo? Pag wider yung kanyang FWHM, mas mataas siya, ano siya? Homogeneous environment or heterogeneous environment? Kapag homogeneous kasi ganyan lang yan eh. Pero kapag malalapit sila, makikita mo sila dito, magsasum yan. Okay? Merong mga software na pwede kang, let's say, may ganito ka, tapos alam mo ilang component, makukuha ng software na yon yung peak ng component na present doon sa sample. All you need to do is put some, let's say, alam mo tatlo yung ano, mag-ano ka lang ng ganyan, okay, tapos ganito yung main ano mo. So, i-calculate niya, tapos ibibigay niya sa'yo kung ano yung mga peak na yun. Okay? And I experienced that. I'm not sure if you're familiar with the software Igor. Okay. So, ang gagawin lang namin yung titingnan namin, okay, so ilan ano dito? Dalawa to. I mean, masyadong mataas tong peak na to. So, we try to simulate. So, let's say ganyan ka ano. So, lalagay kami ng ganito. Tapos yung parang iaano namin simulate. So, dapat yung total peak nung tatlong peak na to kagaya doon sa na-observe namin. Okay. So that's how useful right now. So parang ano na nga yung computational, di gaya noon na talagang at least naman na ano ako na yung may lumalabas na absorbance, because in HPLC meron kaming ano yung platter. Yung talagang parang meron kang tinta tapos ano niyo yung chromatogram. Okay? So, sa tingin nyo, paano namin ino-observe yung concentration kapag ganito yung platter namin? Kinakat namin yung chromatogram, tapos wini-weigh namin. So, okay, ito yung concentration, ganito yung itong concentration, ganito. Which is really a simple one. But at least for the spectrum, at least may nakita man kaming yung tawag doon, analog, but it still give us to a certain number. Kayo yata puro number na lang yung nalabas eh. Have you seen a spectrophotometer na analog? Yung parang may mga number na ganyan tapos merong
Hindi na po, sir.
hindi na? Wala na yan sa IC?
Wala na.
Puro ano na lang, number na yung kung ano man yung 0.123. Tapos mag-aaway pa kami. Hindi, naka-align yan doon sa... It gives you both the transmittance and the absorbance. Nag-aaway pa kami. Hindi yan. Wala na rin kayo yung Sartorius na kailangan magmamatch yung line? O meron pa rin?
Parang wala na po ata, sir.
Ano ng kulay? Yung ano na? Ano ba yun? Orange brown? Wala na yung dirty green?
Parang wala na, sir.
Pagdating sa 32, tig-isa. Sabi namin, hindi, unahan kami sa balance.
Pero parang apat na yung balance ngayon eh.
Sabi na ata namin noon eh. Pero yung orange green pa rin. Yung orange brown. Hindi na rin.
Puti, parang puti na po lahat, sir eh.
Puti na lahat. Number na.
Apo.
Oh? Kaya pala apat lang. Kasi noon, I think mga 8 ata, tapos 4 na dirty green. So kapag naunahan ka doon, either mag-antay ka o gamitin mo yung luma. Okay? Ay, at least ngayon, ano na lang kayo, paglabas yung 4 na decimal places na, di ba?
Apo.
Madali na lang kayo ngayon. Sa amin talaga, ang hirap noon eh. So, kapag makita natin tong ganito, we could say yung plot ng spectrum is just essentially a summary. Okay? Nung spectral information. At you can get it from any what we call spectrometric technique. Okay? So what happened here, it indicates the wavelength to use for maximum analysis in order to obtain the maximum signal. So usually, kapag wala kang alam about sa reagent mo or about sa analyte mo, ang first na gagawin mo is you scan it. Okay? So kapag nag-scan ka, usually ganun yung makikita mo, right? And then the next thing that you're asked is to get the lambda max. So yun yung titingnan mong lambda max na yun. Tapos titingnan mo, okay, if I change the concentration, is there a change in the signal at that wavelength? So once you get that, meron ka nang magagamit for quantitative analysis. So this is really very simple and still useful at present. So yung analyte spectrum along with the spectra, nung concomitants, okay, it allows the wavelength of analysis to be chosen both to maximize the analytical signal and to discriminate against the background signals. Okay? Ang mahirap kasi minsan, yun nga, yung presence ng concomitants. Minsan, yung concomitants mismo, nag-e-emit siya ng signal na pwedeng i-mask out dun sa sample. So, the way that you're going to do is you have to find ways to remove that interference signal coming from that concomitants. So, doon yung parang mag-optimize ka. Minsan, you just use the suitable solvent, matatanggal na yung concomitants na yon. Tapos yung solvent din, you have to take into consideration, they themselves emit spectra. Okay? So the best way that they do is you blank subtracted yung solvent mo doon sa sample mo. Okay? So it become part doon, tinatawag na blank. Now, yung spectrum kasi, we could say, that's the basis of qualitative analysis. Okay? That is also the basis for your quantity. Now, for qualitative analysis spectra, okay, kailangan mo yung tinatawag na numerous resolvable peaks. Okay? And if you're going to look at this, yung spectra ng mga atoms sa UV, sa visible, tsaka sa near IR region, they arise purely from electronic transitions of the outermost valence electron. Okay? So, when we go to that part, dyan yung makikita yung DD transition, okay, yung PD transition. So, it's just the transition of your valence electron. Okay? Yung question nga na pwede kong i-ask bakit colorful kapag metal? Ano yung transitions na meron doon sa metal, right? Copper, ano yung associated color sa copper 2+? Tandaan nyo pa? So where's the copper now?
Blue.
Blue. Ginagawa pa ba yun?
Hindi na, sir.
Hindi na.
Ano po yun Chem 16.1, sir. Where is the copper now?
Kailan nila tinanggal? Kasi lahat ng taga-UP, pag nag-Chem 16, yun yung first experiment Where's the copper now? Classic yun, Jeb. Okay? So it has something to do with the DD transition, which we're going to learn when we go to absorption. Okay? So because the quantized energy levels are relatively far apart, the atomic spectra are narrow line spectra. Okay? So, pwedeng maano natin dito yung tinatawag na resonance transition, wherein this is a transition to or from the ground electronic level state. Okay? Tapos yung resulting spectral niya yung tinatawag na resonance line. So, usually ito lang yung hindi nga natin ito makikita Ito yung basis ng AAS. Okay? So let's say sodium will have one that is intense doon sa yellow region. Okay? Ganun din let's say yung calcium, ganun din yung Fe. So you can monitor them at a certain wavelength. So I think next week we're going to do AAS of manganese. Okay? So i-align lang namin yung wavelength doon sa kung saan maximum yung manganese. Okay? Now, atomic spectra are often quite simple because many of the possible transitions are forbidden transitions. Walang nangyayaring transition. Okay? So, ano lang siya? Yung transition na possible lang, yung makikita mo dun sa AAS. So, atomic spectral lines, they have a finite width, typically much less than 1 angstrom. So, even though the transitions are between two distinct energy levels, because of the line broadening due to lifetime effects, the Doppler effects, and collision. So we will learn more about this when we go in AAS. Diyan yung ano yung tinatawag na Doppler effect. Okay? Now, there are three, we could say, different types of molecular spectra. So anong pagkakaiba ng molecules doon sa atom? So usually molecules is made up of atoms. Okay? So yung atoms, ang transition lang ng ano doon, yung electron. But if you have a molecules, they have quantized vibrational and rotational level. Okay? So because of that, okay, mas wider yung parang scope niya. Kasi cover pa rin niya yung tinatawag na electronic level. Okay? Sa AAS kasi, you are limited doon sa electronic level. Wala kang vibrational or rotational. Atom ka lang eh. At least if you're a molecule, you're made up of more than one atom. So you can rotate, you can vibrate. Okay? So because of this, magiging more complicated yung spectra ng molecules. Okay? Compared doon sa isolated atoms. Yung atoms parang line lang eh. So yung line na yun, nagko-corresponds lang doon kapag na-absorb yung electron, yung energy, tapos pupunta siya doon sa energy, higher energy level. So in the molecular spectra, we could say there's three distinct types. So meron tayong tinatawag na band spectra. Yung pa rin yan yung tinatawag na electronic spectra. So you observe it in the UV, the visible, and the near IR. Okay? Of the spectrum. And the main reason for that is due to the transition between vibrational and rotational level in one electronic state to vibrational and rotational level in another electronic state. Okay? So, dito yung papasok yung ayaw kong i-discuss yung mga harmonic oscillator. Okay? Kasi masyadong PChem. And hindi ko forte yun. I will have to. May PChem kayo, di ba? Kay Dr. Manalo?
Ako, sir. Ngayon do. So, 5.
Meron ba siyang discussion about spectroscopy? Related
Wala
kasi
pa.
yan eh. Ha?
Wala pa po.
Pero meron, nakita niyo sa handout niya?
I think soon po.
Parang may harmonic oscillator nga po
Opo,
dun, sir.
meron.
Kasi yun yung mga ganun-ganun eh. Yung ganyan. Tapos, so dyan na yung energy level nito. So kapag may vibrational, ayaw ko nun. Hindi ko alam. Ano, kasi mathematical yung ano doon eh. But you can what we call explain it on that what we call level. Okay? So yun yung makikita yung in-depth transition na nangyayari doon. And the band spectra, different ano niyan, yung itsura niyan. Kapag sa gas phase, makikita niyo matutulis siya. Okay? Now, in the condensed phase, what happened? Much of the structure of the molecular spectra is blurred because of the frequent molecular collisions and level perturbations due to the near neighbor interaction. Pero kapag liquid ka na or solution, yung tig-isa niyan magiging broad peak yan. Okay? So typically 10 to 100 nanometer. Kapag isa estudyante ko, kapag masyadong ano yan, tawag natin concentrated, wala kang makikita. Nakita niya ganun, Professor, what's wrong? So parang mga 3 ata or 3 dito tapos lampas daw. I always keep getting this din sa propolis sample niya. Sabi ko, i-delete mo. Because you don't get any information on that. Okay? So ganun yung tinatawag natin pag-solution. And may computational ba sa PChem nyo? Because you can see the difference. When you do a gas phase, a calculation in gas phase, makikita nyo parang sharp, ano lang, yung transition na meron sila compared doon sa condensed phase tsaka doon sa solid or liquid phase. So I don't know if you do calculation. But if you want, you can ask Dr. Aguila. I think he was able to get the Gaussian software that I left. Dr. Manalo has that. Kung gusto niyo mag-computational, nagbigay ako ng copy sa kanya nung umuwi ako dyan. So I'm not sure. Gumagamit ba siya noon? Hindi. Meron kayong ginagamit sa PChem nyo? Na software?
Wala
Wala?
pa po.
Yeah. It's a useful one. So I know Dr. Tapia has a copy. Ang dami kong iniwan ng kopya. Nandiyan pa ba si Sir Plerido? Sa PC?
Apo, sir.
O retired na?
Parang nandito pa po ata, sir.
Nandiyan pa rin. Gumawa din siya ng copy kasi sabi ko, I have one here. It's a multi-user galing dun sa boss ko. Kasi yung PChem nila dito is more on computational. So,
Ang ginamit lang po namin yung games.
Games? Ano yun? Sa internet, di ba? Or,
Yes, sir. May software din po siya.
may software din siya. Kasi merong games kasi, nakaano yung parang cluster. Okay? Ang problema nga lang dun sa Gaussian, dapat mabilis yung computer mo. Or else magdamag ka
rendering.
The bigger the molecule, the longer. Okay? But that's one way for you to see them. Yung band spectra. Nakaka-calculate siya ng nung mga information. Ang ginamit ko lang yun because I try to compare the theoretical IR and Raman spectra. Okay? Pero useful yun. I'm not sure kung familiar kayo yung mga ganito. Humulomo ba yun? Is it humulomo or homolumo?
Lumo po.
Lumo,
Homo.
no? Lowest unoccupied molecular orbital, highest occupied. Yeah. You can get that information from that. Okay? So another one that we have, we could say yung vibrational rotational. So I told you, all of them is just based on these three transition. Okay? So ito involves transition from the rotational level of one vibrational level to the rotational level of another vibrational level. So dito yung harmonic oscillator that explain the IR. Now sa IR, yung rotational structure nung IR, nawawala siya pag condensed phase. Okay? Tapos yung last, yung tinatawag natin rotational spectra. So this is just a transition from one rotational level to another rotational level of the same vibrational level of the same electronic state. And I think this is a purely rotational spectra observed in the microwave region of the spectrum. Yung Raman scattering, it also gives information similar to this one. Okay, yung tinatawag na vibration state. So if we're going to look at these vibrational levels, we could say it like here, the B double prime with B prime here. Okay, so meron kanyan dito, meron dito. So yan yung vibrational level. Tapos yung rotational level ay yung sa J. Okay. Tapos yung three arrow types na makikita mong transition. So yung electronic, ito, from a lower energy level to a higher energy level. Okay? Tapos yung X is the electronic. Tapos yung vibration rotation, you could say that's the Y. So ito yun. Okay? And then yung pure rotation niya, yung C, ito lang. Within the same vibrational level and electronic state. So yan yung difference ng tatlo. Okay? So maybe ito yung bago sa inyo. Kung paano yung makikita yung different transition na meron sila. Okay? And it's really useful to explain what is happening, especially kung bago yung, let's say, na-synthesize mong reagent or chemicals. So you can have explanation on that. And computational analysis or computational calculation, theoretical calculation will be helpful to describe ano yung nangyayaring transition. Okay? So, yun yung spectra. Okay? So, the next one that we're going to do is optimization of the response function. So, it's not enough that we can see the signal. What we need to do is to enhance the signal that we get from that. And by doing that, you just have to optimize. Okay? And we could say here, yung dependence ng calibration function on all possible variable, it cannot be realistically be determined. Parang sabi mo, oh, jackpot, nakuha natin. Nope. Okay? There are variables or factors of interest that depend upon the technique and particular application, and this can include this thing. Instrumental variables. So yung tinatawag natin excitation light source. So anong effect, let's say, kapag tungsten, yung light source mo compare, let's say, sa laser. Okay? Tapos sa laser itself, anong, let's say, difference nung mababa yung power kaysa sa mataas na power? It's not, ibig sabihin ng powerful and maganda. Because I see, like inorganic sample namin, taas ng signal. Yung parang ganun. Tapos after 5 seconds, wala na. Tapos makita namin yung sample namin, ano sa tingin niyo makikita namin? Sunog. The power is just so much. So at the beginning, ang taas niya. Tapos, pag ano, bigla. Kasi I ran some stuff with my colleague in organic, ano siya. So meron siyang prepare. So we want to look at the link doon sa metal complex kasi tsaka doon sa ligand niya. So noong una sabi ko, Rita is so good. Tapos bigla na lang, tapos ang tinignan namin sa microscope, kita mo yung surface niya parang may dark something Sabi namin, ay, nasunog. So that's the thing that you need to what we call take into consideration. Okay? So yung volume of element at total sample in the instrument that is actually probed, and believe it or not, itong slit width. Hindi porket mas malaki yung slit width, mas mataas yung signal mo. Okay? Kasi yung slit width kino-control kung gaano kadami yung or gaano ka-wide nung light na maipapasok mo. Okay? And then the physical and the chemical variables, temperature. So sometimes if you're working with biological sample, kailangan mo yung cold condition. So refrigerated. So meron kang parang ano doon, refrigerant to keep thermostat. Kung kailangan mong mababa yung temp, okay, you want to maintain it. And then the pH. The ionic strength. So sometimes you want to use a certain ionic concentration. Yung reagent concentrations and concentrations of the concomitant species, lalo na kung mag-i-interfere siya. Okay? So those are the stuff that you need to optimize, and you can only what we call determine it if you're going to play around doon sa variable. So ang style dyan, anong style dyan? One at a time. Okay? So pag binago mo yung variable, isa-isa, hindi pwedeng dalawang variable agad yung baguhin mo. So let's say if you want the pH, so mag-play ka ng pH, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. Tapos kung ano yung mataas na signal noon, yung next variable naman, so yung temperature. You cannot do it all at the same time. Okay? Although there are some software that can give you just input the initial data from a certain condition, and they would try to tell you, okay, maybe you can try at this condition. Okay? So the results of everything here Results of studies of the influence of these experimental variables are used to choose the optimum operating condition. So hindi lang sa chromatography nag-optimize, right? Pati rin dito. The idea here is to get the maximum signal that you can get. Okay? Now, let's look at some of the evaluation criteria sa spectrochemical techniques. So what are these practical considerations that you have to look on? So you look at the factors to be considered to choose a spectrophotometric technique. Okay? So you look at the cost, the sample size required, simplicity, portability, and robustness. I remember sa 230, meron kayong isang question doon, di ba, about paint. Tatandaan niyo yun? Ako kasi nag-grade kaya naalala ko. Lahat naman kayo tama doon sa ano. So alin spectrometer yung gagamitin nyo, yung more sensitive o yung isang multi-array, okay, na hindi na naman sensitive. And I think the right answer is yung multi-array kasi gusto mo mas marami yung output na makukuha mo. So it has to depends, ano ba yung gagawin mo? Okay? So ang cost kasi minsan sabi nila, the more expensive, the more sensitive. But sometimes hindi naman kailangan sensitive eh. Right? So you have that to take into consideration. I remember when we're doing this propolis stuff, so ginagawa ng bata ko, yung cubette. Now not knowing that a year before, may binili yung colleague namin na yung tinatawag nating microplate reader. So hindi ko alam na pwede pala mag-absorbance do. So nung nag-try kami, graduate na yung bata, pero ang ganda ng mga data niya, pero grabe yung ginawa niya. Kasi he's using ml volumes. Sa cubette, the maximum that we can have is what? Gumamit na ba kayo ng, not cubette, yung microplate well? Yung 96 na ano, well? Ano usually yung volume doon? So you can get around 300 microliter. So from the 3 ml na ginagamit ng bata ko doon sa cubette, we're able to cut down doon. At mas marami pang sample. Okay? It's very simple, easy to use, tapos robust pa siya. It's a little bit costly compared doon sa tinatawag nating typical spectrometer. Okay? But mas marami naman yung output niya. Right now, they have, they call Dueta by Horiba. It do absorbance and fluorescence. Nangako ako dun sa ano, if I have the 20K, I'm going to buy that. 20K lang yung bigay sa akin. So you do both absorbance and fluorescence. Okay? So you take into consideration nga yung speed of analysis. So sabi ko nga, pag meron kang microtiter plates, matatapos mo agad yung assay at ang dami mong data. Okay? The time of preparation is still the same as you use the 3 ml cubette. Okay? Yung matrix modification, I think is much better because you're only using small amount. Although it's the same ratio as the one that you use in higher amount. Calibration, you just do the same thing there. Okay? Now, yung isa sa mga ano ngayon, most of our instruments are what we call automated. Ikaw, Emil, di ba nag-industry ka?
Apo, sir.
Automated na ba yung mga ano nyo doon?
Sir, yung handle ko lang na UVVs ay may zipper na.
Ha? Hindi pa?
May zipper. Sir, hindi na po na kami gumagamit ng cubette.
Oo.
So, diretso po sa test tube.
Oh, that's
Sinisip
good.
na lang po nung ano.
Kasi,
Pero hindi pa po automated na iiwan mo siya. Hindi pa po.
hindi pa rin. Kasi I think the one that is automated is the chromatography.
Apa.
I
Yun pa lang
never experienced, no, I think Lloyd, I don't know if you know Lloyd Mamalis and Marvin Bilog.
Kailan ko ba si Marvin?
O yun, siya yung in charge doon sa lab na tuturuan ko bukas eh. Ano lang siya, automated na kasi yung reading niya time dependent. So microplate well, tapos sasabihin mo kung gusto mo every 1 hour. So isiset mo lang siya. I'm going to, you read all of this? Okay, sorry. Just sit na, dali. Assign it before go to school. So parang ano yun, in 24 hours, so magbibigay siya ng reading. Pero ang ano lang doon, ilalagay mo yung microplate well, and then that's it. Isiset mo lang that you need 1 hour reading per 1 hour. But that's the automated that I know about tawag dito, spectrophotometer. Other than that, wala. Pero alam ko, pag chromatography, kasi naranasan ko na rin yun eh. You just input the program, kung alin yung i-inject, okay? Yun na yun. Tapos magsabihan mo lang yung nasa lab, oh, if anything, something happens, let us know. Pero mas high-tech pa nga after umalis ako eh, kasi nakalink doon sa isang website. Kapag pumalya yung run, makaka-receive ka ng text message. So takbo ka lang uli sa lab. But not in spectrometry, yung automation hindi pa rin, tsaka yung multiple species capability. Okay? Usually kasi kapag meron kang automation, the performance of tasks without operator assistance can free the operator of tedious tasks. And it increases the precision due to a more reproducible performance of step formerly requiring operator skill. Kasi meron ka ng auto-injector eh, at least doon sa LCMS or GCMS. But here, ano lang yan, yung parang ang style ng automation niya, okay, after 1 hour, turn on yung light source and then get the absorbance or emission, kung ano man yung gagawin. Okay? So, after nun, ano na uli, tigil na uli. And then after that, mag-on na naman, tapos titingnan yung signal. Kasi hindi rin maganda yung matagal yung naka-expose yung sample doon sa light source. Kung biological species yan, pwede siyang mag-photo bleach or worse, mag-denature. Ganyan yung problem namin sa laser noon. Tuwa kami, naglalaro kami sa laser. Tapos lahat ng sample namin, bakit gano'n? Si Marvin, marunong mag-ano yun ng laser. Mas magaling pa mag-ano sa akin. Mas magaling pa siya. Ang nangyari nga, nauna ako. Tapos, I don't know if you heard Jason Bedad. Okay? So, siya yung nag-ano sa akin. Tapos, after niya, mas magaling siya sa akin sa isa. Tapos, pagkatapos niya si Marvin, sabi nung boss ko, oh, mas magaling pa kay Jason tong si Marvin. Kaya sabi niya, sino ang kasunod? Kilala niyo si ano, I don't know, Jeff, kung kilala o naabutan mo pa si Peña tsaka si DJ.
Apo, naabutan po.
Yun, nandito sila. Pero sa ibang lab sila. Okay? So, when you have automation, I think ito na rin yung ano doon. So, if you have automation, the tasks that could be automated include the selection of pre-programmed instrumental variable values for a given analyte. So, yung ang kay Marvin, is taking both emission and absorbance. Sa emission kasi, yung parang sample niya, tinitingnan kung magpo-form yung THT with the amyloid. Kasi kapag may amyloid nag-perform together with the THT, which is a fluorescent reagent, ang mangyayari, nagiging mas fluoresce sila. So tataas yung emission. Okay? So measurement of spectral signal, the construction of the calibration curve, kung meron ang standard doon, and presentation of analytical and statistical information. Now, further steps that can be included with the automation is yung sample prep, clean up, and the introduction. So ito yung maganda, especially doon sa GC. Kasi kapag tayo nag-i-inject, mas prone tayo sa error kaysa yung sample injector. Kasi yung sample injector, pag may problema doon, so lahat ng injection niya may problema. So the precision is much better kaysa tayo. So minsan kita natin sa taas or sa baba ng line yung liquid na ini-inject natin. Okay? So automation is particularly needed for situations involving unattended analysis of samples at night or remote location. Hindi ko alam kung automated na dyan yung ano tawag doon. Yung fraction collector, kung nasa ano ka, biochem, so meron kang sample, tapos titingnan mo yung, kukunin mo yung fraction, tapos its fraction, titingnan mo kung nandoon yung protein mo. Okay? That can be an automated, and the way that they do, so magko-collect siya, as long as continuous yung ano ng solvent mo, so after every collection, pwede kang mag-read. Usually, ano bang absorbance ng protein? Anong wavelength? Tandaan niyo pa? You look at 280 nanometer. And then, you could see kung mataas yung 280 nanometer, so ibig sabihin may protein ka dun. That is due to the, ano nagkakos sa 280 nanometer na amino acid? Yun yung tinatawag nating mga aromatic rings. Which is, one is the phenylalanine. Okay? So another thing that we can take into consideration ay yung tinatawag na multi-species analysis. Okay? So, multi-species analysis is more convenient with automated instrumentation. Okay? So, you can carry it out by some instruments with measure analyte in a sequential manner, or by others with measure all analytes simultaneously. So the thing that I have here is I use it in LC. Tapos tatlong detector ang linaan niya. Okay? So meron kang tinatawag na absorbance detector, yung PDA, photodiode array, and then ang ginawa namin yung isa papunta siya mass spec, tapos yung isa pinagpunta namin sa fluorescence detector. So nangyari yan, makikita namin, let's say, magse-separate siya, right? So each peak na makukuha namin, mamomonitor lahat ng detector na yun. So parang sequential yung nangyari. Okay? It's so hard to make this sequential, but pero possible pa rin, especially if you can interface some instrument. Pero makikita mo na itong multi-species thing is if you have a separation technique. But as I told you, some of the detector that they have is based on spectroscopy, yung absorbance. Yan yung number one detector. Okay? And if you have a simultaneous analysis, this is faster than the sequential analysis and require less sample for the situation where n spectral signal are measured from one analytical sample. So usually, yung PDA, ano na yan marami kang information na makukuha. Okay? Even a simple PDA, you can get, let's say, absorbance at different wavelength. So let's say 260, 280. So let's say merong component na mas mataas yung signal sa 260 or sa 280 or let's say sa 350. So magkakaroon ka ng signal na 260, 280, tapos 350. So each of them represent a certain species. Meron ng kakayahan na ganun. So yan yung tinatawag natin multi-species. So the last part that we have here is just the interference and selectivity at ano yung mga figure of merits. That that was typically discussed in analytical chemistry. So parang ano lang to, analytical chemistry and then specific sa spectroscopy. So meron kang tinatawag na interference. So yung accuracy ng analysis mo, okay, here in spectrometric techniques can be degraded by interferences. So yung presence ng interferences is really harmful or detrimental doon sa analysis mo. So when we say interferent, this is a substance that is present in analytical sample which affects the magnitude of spectral signal measured for the analyte. Okay? And there's always what we call an interference sa lahat ng bagay, lalo na kung hindi ka nag-iingat. Even yung fingerprint mo sa cubet, it can affect the signal that you get. Okay? So the choice of the spectrochemical technique depends on the expected interferences and their concentration in the sample to be analyzed. So titingnan mo, what technique are we going to use kung saan maano yung interference mo? Okay? So for example, kung yung interference mo is fluorescent, hindi ka gagamit ng Raman. Kasi mamamax out ng fluorescence yung Raman signal mo. Hindi ka rin gagamit ng fluorescent kasi fluorescent yung sample mo. Na kung yung tinitingnan mo analyte hindi fluorescence, you can stick with absorbance. Okay? So once na-choose mo na yung technique, you prepare the sample for the analysis and it may still have to be carried out in a manner that reduces the interference effect to an acceptable level. Kasi hindi mo siya maiwasan eh. Okay? So the only way that you can do is maybe you find a technique that is only selective or selective only to the analyte that you have. So many analytical techniques are quite selective, but there's only few that are truly specific. So ayan na naman yung selectivity versus specificity. Okay? So kahit na sabihin natin selective, hindi pa rin siya specific doon sa hinahanap mo. It may be selective for a group of compounds kung saan kasama yung analyte mo. Okay? So when you say specific, the term which implies complete freedom from interferences. So it's always what we call a hard problem, yung selectivity na yan. And it's make harder if your analyte is a minor compound. At meron pang mas major, yung compounds of major amount that are present. Okay? So ang ginagawa nga, mag-chromatography ka and then you analyze it in spectroscopic method. Okay? Now, the thing that you do is just, maybe this is just a review doon sa figures of merits. So lahat kayo nagte-32. So ako, kayo magbibigay kung ano to. So the characteristics of spectrochemical technique for a given analyte are indicated by several figures of merits. Okay? So sa bawat analytical method, meron lagi yung figures of merits na yan. Accuracy, precision, sensitivity, detection limit, and dynamic range. So tingnan natin yung ano nyo sa 32. Kung paano nyo tinuturo yung mga baka. Ano yung accuracy? Paano nyo inaano yung accuracy? Closeness to what?
Sa true value na tinatawag.
True value, sir.
Okay, closeness to true value. So it indicates how close the measured analyte concentration is to the true analyte concentration in the sample. At paano yung expression nyo dito? Percent? Ano?
Error.
Error. So when you say 1% error, it's indicated the measured concentration is at least within 1% of the true analyte concentration. So usually the accuracy depends on the analyte concentration Okay? Precision and interference effect. So the higher the interferences, mas less accurate yung sample mo. Ito naman precision. How do you discuss it to your students? Closeness to what? Usually yan yung term na ginagamit ko, yung closeness. Closeness to other data. Di ba, pag precision yung nagkukumpul sila, pwedeng close sila doon sa true value or far from the true value. When that happens, they're precise but not accurate. Okay? And usually, precision just shows you the
Repeatability and
reproducibility. Tama ba spelling? Okay, so it indicates the reproducibility of repetitive measurements of equivalent analyte solutions. So kung percent error sa accuracy, ano naman ang number na nagtatel sa'yo kung precise siya o hindi?
Standard deviation, sir.
Okay, standard deviation. Pasit yan! For the relative standard deviation. Okay? So, you can improve precision by maybe repetitive measurements. Averaging of repetitive measurements can be used to improve precision. And once you improve precision, you improve accuracy. Kaya ako, I mean, yung technique namin sa analytical chemistry, I always tell my student, although 3 is the minimum number, no one said that you cannot measure 100 times. So sabi ko, the more that you can measure, tapos pag nakita nila yung nagkukumpul yung mga data, ayun na lang yung gamitin nilang data. Okay? The more what we call measurements that you have, the greater is the precision and the more accurate you will have. It's in your quantitative analysis, di ba sabi nila, the more measurements that you have, the lower the standard deviation will be. So parang merong ang problem doon. What's the minimum amount of measurements that you need so that you can have this percent standard deviation? Okay? So yun lang yung technique yan. Kaya I don't know yung undergrad mo, Amiel, iniiwasan namin yung orgo. Kasi hindi kami makakasynthesize, lalo na walang reagent. Pag analytical kami, kung ano yung lalabas, yun na yun. Yun yung ano namin nung undergrad. Kasi bakit ang daming nadidelay? I don't know kung ganun pa rin yung patakaran ngayon. Yung mga nadidelay dahil lang sa thesis. Okay? Sabi na, papakahirap tayo eh. Mag-analytical na lang tayo. Okay. How about sensitivity? Maraming meaning yan. But when you're talking about sensitivity, ano yung one word na associated yan?
Response, sir.
Response? I'm not sure, but usually yung tumagal sa isipan ko yung slope. Because slope is what? Change in y over change in x. So parang change in the response or signal over change in the concentration. So pag mas mataas yung slope, ibig sabihin mas sensitive siya. Okay? It has a lot of meaning, and later on may isang meaning akong ano nito before we end the class. It usually indicates the response of the instrument to changes in the analyte concentration and is expressed as the slope of the calibration curve. Or the change in the analytical signal per unit change in analyte concentration. Okay? Detection limit. Ang daming meaning nito. Ito yung pagkakaguluhan after ng class natin. How do you define detection limit?
Smallest concentration na madedetect.
Okay, so it's typically defined as the analyte concentration yielding an analytical signal that is what? 3 times the standard deviation, or standard 3 times the standard deviation of the blank measurement. Kapag 10 times, anong tawag mo doon? Kasi the other term here is LOD, right? Kapag 10 times, it becomes
LOQ.
LOQ. Okay, so detection limit is indicative of the lowest analyte concentration that can be reported as being detected with a specified degree of certainty. Now, spectromic technique cannot be used without pre-concentration steps if the analyte concentration in the analytical sample is below the detection limit. So, kailangan mong i-work out muna. Kung mag-pre-concentration step ka, yung resulting sample na ma-prepare mo above doon sa detection limit ng sample. And it's a problem with our AAS. So I have some breast milk sample coming from there in the Philippines. Gusto nung collaborator is to determine the lead or heavy metals. So nag-run kami, katanghan ko, nag-prepare kami agad ng 100 sample. Tapos lahat below LOD. Sabi nung student ko, I think you should have done that. Yeah, I didn't realize that. So nandoon, naka-freezer lahat. Naghahanap kami ng electrochem na kung kaya ma-detect yung sample namin. Okay? So that's the thing that you do. Before you do the analysis, tingnan mo muna kung enough yung na-meet yung detection limit ng sample mo. And ang tawag doon is yung tinatawag natin detectability. So it denotes the term of ability to provide low detection limit. Okay. Now, last but not the least here, yung tinatawag nating dynamic range. So anong ibig sabihin nitong dynamic range? Okay. So it can be specified as the concentration range or analytical signal range which the analytical curve is linear or the calibration slope is constant. Ito yung sinabi natin kanina kapag ganito, so ito lang yung dynamic range niya. You're not going to do anything about that. Okay? So you can define the dynamic range as at the lower end by the detection limit and at the upper end by the analyte concentration where the analytical signal deviates a specific relative amount from the extrapolated linear portion of the curve. So itong low detection limit dito tsaka itong signal na to kung saan hindi pa nagde-deviate yung signal mo. Okay? So we want a linear calibration curve. We prefer that because it's easier to detect an abnormality and because it's easier to work with mathematically. Now, we also want the dynamic range as much as possible to be large because a wide range of analyte concentration can be used without sample dilution. So gusto mo at least, meron kaming ginagamit dito 0 until 1,000. Tapos makikita ko na ganito. Sabi ko, i-cut mo na yan, 500. Tigas pa rin na ulo ng mga kabata. Hindi, cut mo na yan. Sabi ko, wala nang masyadong difference yung dalawang yan. But the reading is high over here. Then what we could dilute to make sure. So yun yung dynamic. You want it to be, kung gusto mo yung ganyan, at least ganito. But if it's like this, so I said, there's no difference between the 500 and the 1,000. So you put your upper limit as the 500. But professor, the reading is higher than that. Then dilute it. Okay. So in some samples, a large dynamic range is not required, but in others, to avoid dilution, if it's linear, then it can be done. Now, you can also encounter yung nonlinear calibration. So anong gagawin mo? Let's say ganito yung sample mo or yung results. So you can always find ways to make a curve out of it. And it's made easier right now with the computers. Kapag nag-set ka ng what we call non-linear na reading, so ang gagawin yung computer, may mga software sila, ibibigay ka ng least square. Ipipit niya yung data to give you a linear fit. Okay? So it's not the end of the world kapag hindi siya linear. Pwede kang gumawa ng non-linear calibration curve. Okay? And then yung tinatawag ko nga sa inyo, yung sensitivity, it can also be in terms of a calibration sensitivity. So ang nangyayari dito, ito yun, as you're going to look at here, it's just the change in signal over change in concentration. The slope of the calibration curve of the particular concentration or the derivative of the calibration function at the particular concentration. So, meron ka ditong DL, yung detection limit mo. So, it indicates the lowest analyte concentration that can be measured with a specified degree of certainty. Okay? And it's open what? 3 times. Okay? Doon sa standard deviation ng blank. Okay? So yung standard deviation ng blank mo, pwede yung i-ano mo as SDK, standard deviation of the blank measurement. Tapos yung dynamic range mo dito, okay, can be defined as DL and CM. Saan yung CM? Ano yung M?
Maximum concentration.
Maximum concentration na see here. Okay? So, yan yung ano, end ng chapter. Hanap pa kayo kung meron kayo. Kung pwede ko lang i-ano to i-scan.
Pwede kong i-share screen, sir. Mukhang may nahanap ako eh.
O may hanap
Pwede
ka?
po ba? Pwede po. Pa-confirm lang po kung tama yung na-download ko po.
Kasi ang daming ano ngayon tawag dito, available sa online Sige lang, share screen, make co-host.
Ayun.
Yan, pwede ka na mag-share. Stop na ako.
Ah, yes.
Kasi
Ito
ilalabas
po ba?
ako. Yan, yan yun.
1988 po ba?
Oo,
Okay.
yan yun.
Ito po yung isa, yung kay Pavia. Tama po ba?
Pavia. Anong ano mo kay Pavia?
Okay.
Fifth na?
Ito yung website po, onelive.ph. Like, search nyo lang po. Tapos, hope kayo na meron.
Nice.
Fourth pa lang ako Yung kay
Fifth to,
Pavia.
sir. Ito yung website, sir, kung saan ko nahanap.
Teka.
OneLive.
Wag na natin i-record to.